Again, thanks for coming. I think some of you saw me in the morning in the keynote. This talk will be more technical, but not really technical. So I decided not to make it too low level, but more abstract, and outline what I don't like about current situation with object-oriented programming, and maybe show you something which we can fix. A few words again about myself, but the more focus on object-oriented programming. I am an object-oriented programmer, so I write Java code and I write Ruby code, and I like object-oriented programming. But today I will show you why so many people hate it, and me myself as well. A few words about my contribution to that. First of all, I'm a founder, creator, and an architect of a Takes framework on the left top corner. Takes framework, it's object-oriented framework for web development. It's like Spring or Play, but way smaller and more object-oriented. Check it out, you'll find it funny. The second, it's EO language. It's a programming language, which I also started about 4 or 5 months ago. It's an experimental language for object-oriented programming. It's compilable to Java, it's JVM based, so it stays on top of JVM, on Java actually, and it's object-oriented. And also I wrote 2 books about programming, also object-oriented. But today we'll start with this quote, which is coming from Alan Kay, who was the inventor of the term object-oriented. And he said many years ago that Java is basically a wrong thing, and as well as C++. So he didn't like what he saw in object-oriented world. He didn't like the way we write, the way object-oriented programming looks. And there are many quotes. I'll show you just a few of them. Another one is coming from Paul Graham. You probably know this guy. He's really famous in the world of functional programming, and now he's a founder of Y Combinator. It's a big incubator in Silicon Valley for startups. If you know Dropbox, if you know Airbnb, this guy is the investor, one of the investors into these projects. And he's the functional programmer, and that's what he said about object-oriented programming. So my point is that nobody likes object-oriented programming now. Well, another one is coming from, you probably know who Jeff Atwood is. He's one of the founders of Stack Overflow. The Stack Overflow is written on Microsoft, mostly on Microsoft platform and in C# as far as I know. So the code is definitely object-oriented, but that's what he said in one of his blog posts about object-oriented programming. And we can find more people saying that stuff about OOP, and they don't like what they see. I checked on Google Trends yesterday the situation with the term object-oriented programming versus functional programming. So the blue line on the top is object-oriented. The red line on the bottom is functional. It's for the 4 last years. So if you look at the graph, you will see that functional goes slowly up and object-oriented goes slowly down. So in general, the world is kind of paying less and less attention to OOP because I think because of the troubles we see in object-oriented programming in Java and other languages and C#. And at the same time, we're moving slowly towards functional programming step by step, even though the popularity is 4 times lower. So you see that the red line stays lower. So in general, still object-oriented dominates the market. We're still writing Java and C# and other languages which are object-oriented. So why is it happening? And can we change something? Can we fix that? I believe that it is happening because of our, I'll show you because of what. This is what, you know this guy for sure, Robert Martin, also known as Uncle Bob. In one of his blog posts, he said, quite good blog posts, I really recommend to check it out. He said that objects are not data structures. And this is what I keep saying as well in my books and my blog posts everywhere. All the theorists, all the people who write about object-oriented programming, they're all saying the same things if they're staying on the side of the theory, if they're not really practical. So they're saying objects are not data structures. So objects are supposed to be some things which are not exposing data outside. They're just self-sustainable. We're not supposed to take the data out. It's not about data, it's all about behavior and all that stuff. So this is a really good quote. Objects are not data structures. But then we move to a more practical side. And we'll look at this book, for example, which is Java in a nutshell. It's not anymore about some theory, it's about practical Java work. And the book says a class is a collection of data fields that hold values and methods. But he said they're not data structures. And then the book says there are actually data structures. They're data fields that hold values and methods. So first of all, values, and then the methods. But Robert Martin says, no, there's nothing about the data. It's all about behavior. It's all about methods. So the objects are not supposed to be data structures. We're not supposed to think about them as data structures. We need to think about them as something else. He's trying to explain in the article what else, and I'll show you now what he meant. But the practical books, they're saying something else. Okay, maybe it's just Java. Maybe just Java made it wrong. Not really. If you check the book on C++, you will see the same. An object is some memory that holds a value of some type. Again, we know the theory that an object is not a memory, an object is not a data structure, but then the book, which is practical, which we read when we want to write some C++ code, then the book says actually it is a memory. And then on top of that, this quote doesn't even say anything about methods. So it's just a piece of memory with some type. Maybe it's C++. Not really. If you look at Smalltalk, the language which is supposed to be purely object-oriented, which is everybody refer to Smalltalk and say that Smalltalk is definitely not like Java. Yeah, probably, but look at the quote. An object consists of some private memory and then a set of operations. So all the practical books which programmers learn when they start writing code, they all saying something which is not what the theory teaches us. So that's what we have. We have a problem between the theory of object-oriented programming and the practical programming. So I think that we should blame the practice for this trend, that the graph goes down, that the trend is actually downshifting us towards functional programming. So it's not the theory which suffers, but that's the practice which turned a good theory into a mess we have right now in Java world and in C# world, in the object-oriented world. And of course, when all these people are saying that object-oriented is a good way, like Paul Graham said, that the object-oriented is a good way to write spaghetti code, I would change that and say Java is a good way to write spaghetti code. C++ is a perfect language to write spaghetti code, but not the theory. I think so. And now I'll show you 6 really like practical things, I'll show you what they mean in theory and then what we have in Java. Again, in theory and in Java. And I'll try to convince you that we must change the practice in order to get back to theory. Let's start with this one, my favorite one. Getters and setters. So we all agree that the objects are not data structures. That objects are some things which are supposed to have behavior. And then in Java we introduce getters and setters. We have book, and the book has a private field, private attribute title, which is supposed to be private, which is supposed to be not visible to the outside. But then in Java, and now after Java, or maybe before Java, I don't really know the history, but there are many languages which do the same. They introduce getters and setters. In Ruby, you can even do it on level of the language, so you don't even need to write these get-set methods. You just can call them, can use a special keyword which will define that stuff for you. So the get title and set title are perfect violators of the theory. So the theory says that the title should not be accessible from the outside. The book is not supposed to expose its title ever, because it's not a data structure, it's not a data holder, it's not a container of data. The title is not supposed to be visible to the outside. But then we introduce a setter and we introduce a getter. So we basically violate the theory and making an object a wide open data container. So my point here, if you have that in your code, if you have that setters and getters, you're definitely doing something not object-oriented. How to avoid that? How to get rid of setters and getters? I'm not going to show you the answers, but the obvious answer is you need to introduce methods which will do something with this title, instead of letting somebody else get the title and do something with it. For example, you have a class somewhere which is taking the title out and printing it to console. So you give the book to that method, to that, I don't know, somebody, and that somebody takes the title out and prints to console. Don't do that. Instead, let that somebody call a method print to console, and then do the job internally. That's the solution. That's the general definition of how you solve that problem. So getters and setters, it's a huge problem. Anytime you see that, you know it's not object-oriented. And I'm sure, how many of you actually use Spring Framework? How many use, Jesus, how many use Hibernate? You know, you see what I'm talking about, yeah. So this is not how Hibernate can work. So if you remove getters and setters, probably you should remove Hibernate as well. You should remove Spring Framework as well. I'm not telling you have to do it tomorrow, but even with the code you write, a new code, not the code you have right now, but the code you're going to create in the future, try to avoid that. Every time you see that you need setter and getter, you're moving away from object-oriented programming towards that spaghetti code. Number 2, static methods. You know what they are? Static method, you know what they are, right? And they're really wrong. Again, I'll show you an example, explain why. So this is the book utils. And we have a static method print. So we give the book to the method print. And then the book, the method print, this procedure print, is doing exactly what I just said. It takes out the title from the book and prints it to console. What's wrong with that, with the static method? Because the method is static, there is no encapsulation anymore. There is no object anymore. So the static method has no connection to any object at all. It's not object-oriented programming anymore. It's just a piece of code. It's just a procedure which is expecting an object to arrive and, of course, expecting that object to expose some data. So we're kind of telling our objects by these methods that we are not objects, you're objects. You come to us and I'm going to extract something from you and then I will do the job. Instead, object-oriented programming is the mindset where everything has to be encapsulated in the object. So only the object knows how to print something. In this example, only the book may have the knowledge about how to be printed. So this text, the title is quotes, has to be encapsulated in the book. Only the book must have that knowledge, not some other method, not some other procedure which stays outside of the book. But when the method is static, it's the only way to work for this method is to be without any encapsulation, without anything, any objects at all. It's expecting foreign objects to come in because it's static, because there's no state at all. It's just a piece of code. It's just a procedure. So again, if you see static methods in your code, it's a clear definition, clear indicator for you that you're not writing object-oriented code. You're doing something else, maybe procedural programming, maybe you're still thinking like C or COBOL programmers, maybe you're in the era of assembly. I don't know where you are, but not in the object-oriented domain. Object-oriented, it's not just the classes and methods which you combine together to get the job done. It's the way of thinking. So you need to start thinking like in terms of encapsulation. So you hide behavior and data together and you never extract it out. You hide it there, and then you compose these pieces together. But you never do it like that. You never extract a title. The moment you extract a title from an object, it's not an object anymore for you. It completely loses control of that title. The title jumps out, and then the book doesn't know what's going to happen with the title. Who is going to print it, in which format, how it's going to look, who will understand the title. It's completely out of control of the book. It will work technically, of course. Many of you, who is using static methods on a daily basis? Just raise your hand, but honestly. You see? Me too. So we are all using static methods, of course. There's no, we're in the Java world. I have to use them sometimes because this is Java or this is, C# or whatever. So we have to use them sometimes. But every time I use it, I understand that now I'm doing something which is not object-oriented. I'm asking you to do the same and stop doing the same. Number 3, null. You know what null is, right? Null reference, null pointer, whatever you call it, it's null. In Java, it's null with the small letters. In Ruby, it's nil. In C#, what it is? Null. Null as well? Yep. Yeah. It came from C, I believe. So this null, this notation with all the capital N, U, L, L came from C language. In C language, actually, who knows why it's all caps in C? It's a macro, exactly. It's a constant. It's a macro in C. So all the macros in C are all, by convention, they're all capital letters. So there are null, there are many other macros in C, not in C++, but in C. So what this macro means, what it is null? Who knows the value of it? It's 0, exactly. This is technically just 0. It's just the number 0, which is like an integer or long, whatever. It's just 0. It depends on the machine you're working on. But this is just 0. In object-oriented world, there shouldn't be that thing because we don't have pointers. So in C, we had that 0, which meant the pointer to the memory, to the location in memory with the pointer 0. So technically, it meant an address in memory with the position of 0. So the beginning of the memory. And then compilers, not even the compilers, but in runtime, programmers were supposed to understand that if somebody is sending you the pointer, which is 0, it means that they're not really sending you the pointer. So if you expect a book to arrive to me, and then somebody sends me not the book, but null, but 0, it means that that means to me as a consumer of the book, that I shouldn't go there to that memory and get the title from there, because there is no title. I will definitely get segmentation fault if I do that in C language. So that's what most of the segmentation faults are coming from. When you see them in the console, the command line application written in C, if it crashes and says segmentation fault, in most cases it means that they are trying to refer the piece of memory by the wrong pointer, and in most cases the wrong means null. So if that would be C code, and I call the library and I say, hey library, find me the book by that title, and the library returns me book, that B, so in C language that would be a pointer for 8 bytes. 8 bytes saying this is the location in memory where you can find the book. And then if I remove that if and I just directly go to there and say this is the book plus B, for example, get title, then in runtime the CPU will go to that memory and try to find the title. But the address is 0. And by the address 0 the operating system is located. So it's a private zone. Nobody was able to access that. And the system will say segmentation fault. So you're trying to access the segment which is not allowed for you. So I'm trying to access the segment which is not mine. That's why segmentation fault. It's not happening in object-oriented languages in Java. We don't have pointers anymore. We're getting the book which is supposed to be an object. But we inherited the idea of null from that old languages by mistake. And there is a quite popular presentation by the programmer who, as the Wikipedia says, invented this null pointer. You can Google it. It's called a $1 billion mistake. So the presentation is called a $1 billion mistake. And there, at the presentation, he admits that that is a mistake, and it was made many years ago, and it cost us billions of dollars because all these segmentation faults and null pointer exceptions and all this if-else are coming from that wrong idea of having 2 different types for each value, the book or the null. Here what's happening, if you talk about object-oriented, here look at what's happening. I'm getting the book and then I'm deciding, are you a good book for me or you're a bad book for me? Can I work with you or I can't work with you? Are you a proper object or you're not good enough for me? This, again, a violation of encapsulation, I believe. Because only the book can know whether it's good or bad for me. I should not make that decision outside of the book, outside of the border of the book. So here's the book knows what's going on, the book has the title, the book knows...
There is no book.
There is no book, exactly. So if there is no book, throw an exception. If there is no book, if the library cannot find the book, throw an exception and say, I can't find the book. But how come the library found something, returned something, and it's not a good book? That's just a wrong way of thinking. So the library transferred the responsibility of making a decision of whether it's a good book to me, a client. Instead of returning me an object which encapsulates everything, the library said, I don't know, I didn't find it, and now you decide whether it's a good object for you or not. What happens is that we have all these if-else or null pointer exceptions everywhere, and we get the spaghetti code. Because we break encapsulation. That's the point here. There's no encapsulation anymore because the book is not in control of itself. The book doesn't control itself. The book is, sometimes it's a book, sometimes it's null. And every time I need to check and check and check. So the code becomes longer, difficult to maintain, and all that troubles come in. So just remove the null. That's my point. So every time you see null in your code, it's a red flag for you. It means you're not object-oriented anymore. You're doing something else. You're in C programming. You're a long time ago when it was like that. They didn't have exceptions by that time. They didn't have exceptions in C, so that was the only choice for them to do that null. So they were trying, for example, to open the file, but then the file is not open, and they were returning -1 sometimes. You remember that problem. So besides null, they had other nice design ideas. So they were asking you to open the file until the file can be found, and then return you -1, and then you're supposed to go somewhere else and find why that was -1. And then the error code is located over there. That was a C nightmare for error handling. And then they introduced exceptions, like which we have right now in all modern languages. They didn't have that. So null is inherited from that time, from 30 years ago. If you still use this, if you use it in your code, completely wrong. If you need to use it sometimes, like in this example, let's say the library is not my code. The library is like a framework. So I can't do anything. Okay, I'm expecting this, I'm calling find, and they return null. I'll look, for example, this method from file. If you say file.find or something like this in Java, so if you want to see all the files in directory, then you call file.find. It's a static method. If there are no files in the directory or no directory, they return you null. Now, if there are no directory, they throw an exception, but if there are no files, they don't return you an empty array, they return you null. So if it's one file, it's going to be an array with one item. If there are no files, it's going to be null. I'm still questioning myself who invented that design, but this is what we have. So if you have that, of course, use that and introduce this if not null, if null. But with your code, stay away from null as far as you can. Point number 4, and I really hope Anton would not be here, but still, I have to say it. So reflection, if somebody was on the talk before, there was a huge discussion about reflection and how you can actually, disassemble your class and change it on the fly and inject something there and then take something out. Well, it's a good approach for hackers, I think, but it's not really good for designers. So if you really need to do that, if you really need to do something with your code on fly and extract something from it and replace classes and reload classes, that means that could be only one excuse, that you're developing some framework, some really low-level framework which will be used by designers later. So in this case, you can't be a hacker. But if you are a designer and you're developing some business application and you need to reload classes on fly, then this is definitely doing something wrong. So it shouldn't happen. So you shouldn't do that because it makes the code, because the object, again, speaking about object-oriented programming, the objects are not supposed to be disassembled on fly, and we're not supposed to take any attributes from out there or inject some methods in there. The object is kind of a sacred and completely solid and robust and untouchable black box. Should be. So we shouldn't touch anything from inside of it. Absolutely not. Again, the only excuse is that you're developing something which hacks Java. For example, we're now developing the language, this EO language, which I mentioned before, EO language. So now, because we're developing the language, we may sometimes need to hack the JVM, and that's why we may need to use this reflection. But if it's a traditional application, completely stay away from it. And not just reflection, but also typecasting. Look at this code. We're taking the book out of the library, and then we're deciding if this book is actually electronic book, then I can get the PDF from it. I'm sure you've seen that type of code in your products as well. So this is called typecasting. Instance of checks what is the type, and then typecasting happens. This is really wrong. This is a bad code. So if you need to do that, again, you're moving away from object-oriented programming, because only the object has to decide whether the get PDF is there or not. You should only say that this is the contract you need to work for. You're the book, you come to me, there's the contract, I'm expecting the ebook, or I'm expecting just a book. And then the client decides what to provide, and then you work by the contract which you declared. But you should not check in runtime like that. You shouldn't check the type of what's coming and change and typecast in runtime. Again, because it violates the encapsulation. You take the control out of an object. Object doesn't make a decision anymore. You're making the decision. Who is black, who is white. I have an article on my blog which says that typecasting is a discrimination. So I'm kind of comparing discriminating people with discriminating objects. In this case, exactly the same is happening. So the book is coming from the library. And then I'm saying, hey, if this book is white, then you can come in. And if this book is black, then no. Or if you're male, you can get this service. You're female, you're not going to get this service. Exactly the same is happening here. So I'm deciding what kind of book is this. And then according to that decision, I continue my execution. It shouldn't be like that. The book is a book. The book is coming from the library, and then I can say, okay, get me the PDF. For example, I want to assume that I need the PDF in any case. And then the normal book, which doesn't have the PDF, will throw an exception and say, hey, I don't have the PDF, for example. And then in that case, I will introduce another method which will say, find me the book which has PDF. And then the book will be returned. But I shouldn't make the decision after the book is in front of me which kind of book it is. That's the point. So it is a discrimination. It's wrong. It shouldn't happen. Again, if you have instance of, you have typecasting, think what's going on. Shouldn't happen. We have two more, and then I'm done. Inheritance. You've probably heard about that inheritance is bad, or inheritance. There are many articles saying the composition over inheritance, something like that. So inheritance is a practice, is something which was introduced in C++ or in other programming languages. I don't even know exactly when, but it is a technique. There are two things actually: inheritance and subtyping. So subtyping is a good thing. Subtyping, you know what it is. It's like you need a book. Here's the ebook for you. This is subtyping. So if you want a book, then ebook will work for you. This is the principle which is also known on a wider, if you like, on a more generic scale. It's called Liskov substitution principle. So which literally says that if the book is required, then a more specific book will also satisfy the contract. If you want just the book, if you want an animal, then the dog will work. That's basically subtyping. That's perfect. Without subtyping, we cannot have object-oriented programming at all. We need subtyping. We need to be able to provide more specific things when more generic things are required. But inheritance, which is also known as implementation inheritance, has almost nothing to do with subtyping, and it works like this. On the left, we have the manuscript. It's like it's not a book entirely, but it's a manuscript. It's something which has a title. And then on the right, I have a book which extends the manuscript. So it's more specific thing. And then that book basically copies parts of the manuscript and reuses them. So implementation inheritance was invented as an instrument for code reuse, not for subtyping, not for making interactions between objects more convenient, and like in the example with the dog. Here's an animal, you want an animal, here's a dog for it. This is a completely different thing. It was invented to help us reuse the code, which we don't know how to reuse in a better way. So we have some class, most probably with 200 methods, like an Android sometimes, and then I have another class, and I need this, and that. So I need that 5 methods from there. And we're just too lazy to break that huge class into pieces and move that functionality somewhere into smaller elements which I can encapsulate. No, I'll just say, okay, I'm going to extend that one. That's a big monster library of methods, and then I extend that library and I get that methods over here. That's what implementation inheritance is for code reuse. Of course, it leads to messy code and spaghetti code eventually, because the links between this class and that class are really tight. They're really linked very hard, because any change on the class on the left will cause troubles on the class on the right. And they are linked very, very, very tightly. Not through the contract, not through a few methods calls, but it's actually getting access to the protected property over there. So this title, it's not declared over there. It's an attribute from the parent class. So the connection between them is really tight. And when you have multiple, well, in C++ you can have multiple inheritance, but in Java you have single, but still you can have many levels of inheritance, then eventually you will have definitely spaghetti code, which has nothing to do with object-oriented idea. Because in this case, the class, the book, the manuscript, sorry, it's not a closed one, it's not a solid black box anymore. It's something which is available for extension, so-called. It means that somebody will come later and take piece out of me, will access my string, my title, will access my method, will do something with me. So that's, on object-oriented level, conceptually, that's a wrong idea, to have in their inheritance in general. So I would suggest to remove that word at all. So just don't use that keyword and it will be fine. Just don't use extends. Well, you're going to use it for interfaces. Okay, I'm sorry, you have to use it. But don't make sure that your classes never extend other classes, just never. And then you will be fine. Of course, you will have troubles in the beginning. You will ask yourself, how do I reuse the functionality from another class? But then you will find that you can encapsulate that pieces of functionality into your objects. encapsulate, like make them, like for example here, look, we have this title, which is of type string, and it's coming to us with the entire set of functionality. We're not extending it. We're not extending the title. Even though we can say that, look, the manuscript can extend the title and take all the functionality from there, including substringing and what else do we have in string? Like all the features which string have, like finding a substring, like making a substring. But it's not happening. We encapsulate this functionality. We don't inherit it. We encapsulate it. The same should happen with all objects. Okay, and the final one I'm finishing. My favorite one. No, getters were the favorite. This is the one I hate because it's difficult to explain, but still I'll try. So annotations, you know what annotations are, right? They exist in C#, right? Exist, yeah. They don't exist in...
attributes.
So again?
In C# they're called attributes.
Attributes, that's right, okay. But in Java it's annotations, in C# attributes. In Ruby they don't exist. In PHP they didn't have before, but they can sometimes they put them into this documentation blocks. Anyway, they work. You most probably know how they work. So we have on the left, I have a book. I have a book, and then on the right, I want to print that book into XML. What do? I don't want to put the entire functionality of converting a book into XML into the book class, because it's not so easy, it's quite complicated, it's like a few pages of code. So what do? I annotate the book, I put the annotations there, and then I create another marshaller, in this case, so another machine or engine, which knows how to work with that object of that class according to the information from the attributes. What's wrong with that? Everything. The main thing is that now we have two places where the functionality is stored. So now the book doesn't know a thing about XML printing. It doesn't know what's going to happen. It doesn't know how this data will be used outside. Actually, this is supposed to be public, not private. So I made a mistake in my slide. So this is supposed to be private. Oh, sorry, public. In order to give access to these guys to extract the data and use them somehow. So in my book, which I brought with me, I made an example explaining the annotations. I made that metaphor that getters is like when you go to the bar and instead of the bartender, instead of asking you what kind of the bartender, instead of giving you the beer, it just pours the beer into your mouth and takes the money out of your wallet. So this is the setter and the getter. So you're not in charge. They're just putting the beer into you and just taking the money out. And you're like staying there like a container of beer, a container of money. That's all you can do. This is the metaphor for getters and setters. For annotations, that means that you're coming into the bar and the name of the beer is tattooed on your forehead. So you can't even say the title of the beer. The bartender just knows, oh, there you go. That's the XML element. Boom, it takes it out from you. You don't even have a chance to say anything. And this is really offensive to the object. That's what I think. So this functionality has to be inside the book. That's my point. The book has to know what should happen with the XML. Of course, it's going to be more difficult to implement because this approach is easier. Just open an object. And all of the things I mentioned, all the 6 things I mentioned, they're all easier for programmers. So writing object-oriented code is more difficult because you need to think more, you need to make some extra effort to do the object right, but in the end you get objects which are proper objects and you don't have the spaghetti code. In this case it's way easier. Look, do we have a marshaller for XML? Of course, there are like 5 libraries on the market. All you need to do is annotate your object, which is not an object anymore, and boom, you got an XML. Well, it's not an object, but who cares? I get an XML document. Of course, to make it right, you need to think, okay, how do I put this marshaller inside my object and still keep it small? Because now the book is really small, like 4 lines of code. How can I keep it, relatively small, maybe not 4 lines, but 10 lines, but encapsulate all that functionality? How can I also use some libraries, the XML building libraries, to create the XML, but at the same time keep the object small? It's not so easy. It's not going to happen tomorrow with you, but try to start thinking that direction. So I'm leaving some room for questions, and I'm finishing with this slide. So he's saying about C++, not object-oriented in general. So when object-oriented was invented, when the idea is, when we were talking about the idea is right. But when we have annotations, getter, setter, static methods, null, and other brilliant things, then of course we're getting to C++ or Java or C#, and of course then we blame object-oriented programming, and then we start to love functional programming, because functional programming has less problems than that. In functional programming, they don't have many of that things which we trying to ruin object-oriented programming. So I wrote the article about that on the blog. You can check it out. That's the link. If you're interested, everything I said today, mostly everything is covered by the article. So that's it. Your questions are welcome, I guess. Yeah. Try to make them easy.
Yeah, actually, I believe in my opinion, you missed like one point in the beginning. Like, why have you decided that object-oriented is better than what we have got, like in practice? Right?
Yeah, that's a good question. I'll repeat the question for the mic. So the question is why, in the beginning, I didn't say why object-oriented programming is better than Java.
Yeah.
So why OOP is better than Java, and why do we need to remove something and stay away from getters and everything if Java works and we have brilliant Android platform and everything is fine? Well, I think because that's why I tried to show you these 3 slides, people saying that object-oriented programming is actually a mess. I mean, and that's why I tried to explain that they were not saying that about OOP, they were saying that about Java. And I also find, let me ask you the question, do you enjoy, in most of the times, looking at the Java code, which you're getting from the market, the open source code, and you need to refactor it? Do you like it? Who doesn't? Who feels frustration in most cases when you're looking at the code coming from you, from open source and written in Java? A few people, me myself. Well, I think you're just too tired to raise your hands. But I believe if you're not frustrated, if you love the code you see, then probably I'm not going to like your code. But maybe you're from the same part of the camp. Yeah.
Let me elaborate. Like Smalltalk, for example. Smalltalk was like amazing, but it was self-contained. In Smalltalk, if you told Alan Kay that he should bring like a different like XML, whatever, like parser or whatever inside Smalltalk, it was not an idea. Like what I want to say is that what we have right now, it didn't appear like magically or because everyone is stupid and didn't understand what object-oriented programming is about.
Mm-hmm.
Because if you look into 90s, everyone was doing object-oriented libraries. Microsoft, Borland, and so on.
Mm-hmm.
It was like golden era for object-oriented programming. But were programs better in the 90s comparing to now? I'm not sure. Yeah, and what we have got now, it was because we tried to solve like real problems, like for example, separation of concerns. Like we have logging logic in logger class, and we have XML parsing logic in XML class, and we have something else in something. It's really hard to put everything in just these objects. This object should know about everything, about how to log himself, how to sell himself, how to print himself, how to parse himself from XML, and so on. It's like practice just shows that it's really hard.
Yeah, I got the question. Yeah, I'll repeat the question. So basically the question is that we probably, all of this we have right now, C++ and Java and libraries, they didn't show up because some evil developer decided to do that. It's probably the market, if the market developed it because they actually were able to produce some working software, and that's why everything is what we have now actually works. And in 90s, like many years ago, there was a boom for object-oriented libraries and frameworks and modeling and everything, and it didn't really work. So people actually decided to use something more practical and more, easy to use. I think that, to answer that, I think that we never got object-oriented right. So in the beginning, it was an idea, but then we introduced getters and setters in 90s. We introduced null in 90s. We introduced C++ in Java in 90s. So everything was introduced when object-oriented just got into the market. I believe, that's what I remember. People immediately understood it wrong and just understood that objects are just good containers for procedures and data, because most of the people were procedural programming from C era. So there were just C developers who eventually got the idea of object-oriented and said, wow, we're going to understand it. Some of them understood it, but the majority, hundreds of thousands of programmers, they were still C programmers. And then they got C++ or Java in their hands, and then they got some salaries to work on, so they were supposed to produce some results next month. And then they produced what they could produce. They said, hey, do you have static methods? Because I'm used to have procedures and functions. So give me the static method, and boom, you have static methods. So the static, for example, the static method was in Java. For what reason? It was object-oriented language in the beginning. So why static method, which has nothing to do with object-oriented, with objects at all? But it was there because, I believe, because it was a marketing, it was a money question. Because there are millions of programmers in the world, they need to produce code. And in order for them to produce code, we cannot teach them all what is an object paradigm is. We cannot change their mindset. We cannot say that null was wrong and now there is no null. So every time you ask the library to find the book, you can't return null. You have to throw an exception or return the book. That's it. That will be like a revolution. People will say, no, it's not going to work. This is not how we used to design software. And that's it. That's what I believe what happened. I don't know exactly, but that's my understanding. Any more? Yeah. Yeah, just shout it loud. I'll repeat it anyway.
Thank you. The general message of your presentation is returning back to the pure theory of object orientation. That's cool. But at the same time, you compare it with functional programming, where more or less all these 6 points exist and flower. So functional data structures are fully open. Well, optional data types are just type-safe variants of null pointers. But that type-safe is great. Well, what else? Static methods are just functions. So you compare with functional programming and wanted to reject these features that are closer to functional programming in order to gain popularity of not functional but object-oriented programming. So how is it?
Huh. Well, it's a good question. Never heard that one. I asked for easy questions. I don't have an answer right now. Well, I'm not trying to say that object-oriented is better than, well, I'm trying to say that, actually. I think that in functional programming is way more structured and way more based on some mathematical model, I think so. Well, I'm also writing sometimes in Clojure, which is functional language, and sometimes in Lisp, not in Lisp, but like kind of some dialects of Lisp. So, and I enjoy that because well, in a simple way, I don't really enjoy Clojure, but when it's Lisp or something like that, really primitive way, like primitive, for me, because I'm not really a Lisp developer, but for a primitive way, functional looks to me like something which I can't really break easily. So there's not really a big amount of things which I can use. While object program, or like OP languages for me, look like a huge amount of math which I can combine in any possible way. So, but maybe you're right. If you look at the really professional functional programmers of today, they probably have the same amount of math as we have in object-oriented. Maybe that's why the graph is moving so slowly. Maybe if the functional languages, modern languages would be perfect, then maybe their popularity will just go up. Something like that. But now, because if I look at Clojure, I can also say that this is not perfect at all, because they have so many things which I would remove from there. I in general believe that the more we remove from the language, the better the language becomes. So the more features we take out, the more features we don't use, the better is the code we create in this languages. That's what I think in general. So more features means less quality. So maybe that's not exactly the answer you were looking for, but that's all I can say. Yeah.
So going back to your question, or to the part where you said that returning null is bad practice, and I would agree with that, but what about returning optional instead? Do you find it as a better solution?
Yeah, I'll repeat the question. So I said that returning null is a bad idea, but there is another. Returning null is a bad idea because in that case we move the decision making outside of an object, and it's bad. But the question is, how about we return an optional? So instead of returning an object, we return a collection of one element. Optional is in Java a collection of one element, which may contain an element or may contain 0 elements. And in that case, the decision here will look a little bit different, but still it's going to be if then else. but it will be better, definitely, because it's not going to be if then else. It will be, first of all, find me the book, and then let me return the collection, and then let me take an item outside of that collection. And then I will decide whether there is an item or not. So in this particular example, that's a perfect solution. I like it. So this is how actually C++ standard library works, the hash map, for example. In Java, if you go to the hash map, if you take an element out of hash map, you're going to get null or the element. In C++, if you take an element outside of a hash map, then you're going to then they will return you the iterator. So they return you kind of a collection, which then you will have to decide what to do with this iterator, to take something out or not. So Java design is wrong, I think. C++ design is good. So in this case, if you return optional, that would be a good design. In this case. But in general, I would lean more towards null objects. So you return a book, and if the book is not found, I either throw an exception when it's a really exceptional situation, or sometimes we can return the null object, which looks like a book, but if you start touching it, it's throw an exception. Something like that. This is more, Google for null object design pattern, you will see what I mean. But optional is not a bad idea, in general, yeah.
First of all, Igor, thanks for great presentation. I have one question. So you mentioned a lot about solid principles, and I'm a big fan of solid principles. So in the slide when you have like don't use extends, don't you think you kind of violate open-close principles?
I think solid is not open-close. Yes, it's a solid. That's right. Okay. Well, I think that this open-close principle. If I'm correct, let me say what the principle for everybody. So there is a principle in this solid. There is introduced by who introduced the solid?
No idea who.
I think
biggest.
Yeah, it was
Uncle Bob is actually the one who promotes it.
Yeah. Okay, so there's a principle with the O letter which called that the module has to be open for extension and closed for modification. Am I right? Yeah,
exactly.
That's the principle. I believe it's a good principle for modules, for services, for modules, for microservices, for something which are not objects. So an object is not going to be open for extension. An object cannot be open, I think so. An object is something which is closed always. It is created, it's instantiated, and you're not supposed to do anything with it. You cannot open it, you cannot extend it. So I believe, I wrote about it actually on the blog two months ago. So I said that's a good principle, this open-close, but it's not for objects, I think. It's for something bigger, for modules, for example. So if there is a module, then yes, definitely, we have to be able to open that module for extension. So if you give me the module, I should be able to extend your library. I should be able to find a way how to combine pieces together and create bigger pieces. How can I extend, how can I implement your types, for example, and then make it more powerful? And then it's supposed to be closed for modification. So I shouldn't touch your library. I shouldn't modify. All your objects should be like final and everything should be closed. So all I can do is only extend it, but not modify it. It's okay for libraries, but not for objects, I believe. We have one more question, I think. Yeah.
Thank you. It's very thought-provoking. I would say that evolution of programming languages and paradigms is evolutionary. So people will use whatever they like using. So I'm a C++ programmer at the moment. C++ is terrible, but it lets you be whatever you want. You can be object-oriented guy one moment, and then functional guy the next moment, and then metaprogramming and all these terrible things. And this is why C++ is alive and with us. Mm-hmm. And this is why we have functional features in Java and C# these days. So we can call for purity all we want, but people will not listen. They'll just use, as many features as they can possibly find in the language.
Definitely, definitely. I agree. That's a good point. Then we can call for purity. We can ask for brilliant design. But in the end, we of course will have the design we can have for that amount of money, that amount of time, that amount of good programmers and bad programmers we have in the team. That's really obvious that software products are not created by brilliant, bright engineers. They're created just by engineers, just by programmers. Some of them are good. Some of them just started to learn Java. Some of them just found out that there are static methods. Wow. That's great, they can use it just for fun. And then you find the code which was written by somebody who was just experimenting with some language feature. And now this code is in production. Is it good? Is it bad? This is just a reality. So I'm not saying that we need to completely remove static methods and fire everybody who's using them. It's not going to happen tomorrow. But we should start thinking what is good, what is right. What is bad, what is good, what is bad, what is wrong, what is right. So I think that what I mentioned here is just in general things which are leading you towards the wrong direction, but if you remove them and start thinking about objects more, then your code will start slowly shifting towards more maintainable stuff. That's my point. Of course we cannot, it's not, what I'm saying here is too extreme. Of course, if you start programming tomorrow, just like I recommend you here, you probably will be fired. Not the people around you who are using static methods. They will be just start blaming you that you're trying to to turn their code into mess. And I've got many emails like that. So one guy last year emailed me that he changed 3 jobs before he found the job where they agreed not to fire him for writing code like that. 3 times he changed the job. So well, that's probably too much. You have to adapt. You have to do what the money is telling you. Of course, the entire market is about money. So if they pay you for static methods, who cares? But if you start telling them that, you know what, they're static methods, how about we make a bit less of them? Maybe it will be better for us. Let's make, instead of utility classes with 50 different methods, how about we create 25 objects with 2 methods in each one? Maybe that will be better for our users, for people who use our library. And that's how you change the world to a better place. That's it. Thank you very much. If you have more questions, I'll be available. And I have some books.